Hey, what's happening, guys? Today we're going to talk about building your first electronic kit, choosing it, what types of tools you're going to need, and finally putting it all together. So, first, let's assume you're just getting started and you don't have many or any tools, but you want to get into building these electronic kits. Well, the first thing you're going to need is a soldering iron. Now, the one that I'm using today, I'm going to slowly up here and show you, is that one right there. I did a review on it. You can find it on the channel. But any soldering iron will work. Yes, I know all the purists are going to get mad at me for saying that. You must have a temperature-controlled soldering iron. No, not really. It makes things easier, makes things cleaner. And when you get further along, you're going to want one because you don't want to be putting too much heat in the parts. But when you're just starting out, whatever soldering iron you have, it's just going to be fine. Now, when it comes to solder, if you're in a country where you can get leaded solder, then I highly recommend this. This is MG Chemicals. This is 60% tin, 40% lead solder, catalog number 4895-227G. This is a half pound, and it is 0.032 diameter, or 22 gauge. So pretty thin if you're used to like plumbing solder, but this is what you want for electronic soldering. Next, you're going to want a pair of wire cutters, flat bottom wire cutters, for cutting off the excess legs. I know you probably got a pair of wire cutters like this, or if you're younger, maybe your dad does in his toolbox. No, not those. There, you see, there is a wedge against an anvil. You're not going to get a flat cut either side. There's going to be space. So that's why you want the flat bottom wire cutters. Now, if you have big hands like me, you might want a pair of pliers for manipulating smaller components. I don't always use the pliers, tweezers rather. What I generally use are a pair of needle nose pliers, which I hold like this. And then I can manipulate them quite easily, kind of like that. If you're in the medical profession, a set of hemostats is great. You can order these anywhere, even if you're not in the medical profession, but medical people tend to come across these all the time. And this is a plastic wedge, spudger, pointy thing, just a soldering tool. They're just useful. Now, like that's a plastic one. Here are some metallic ones. These are old school ones. Yeah, this is a solder assist. So you have a little tiny hook at that end. A little 90-degree whoop-de-woo there. A kind of a wedge shape there and kind of a screwdriver shape. All these things are great for manipulating the items that you're going to be soldering. Now, you're going to need a way to secure what you're soldering and hold it in place while you're soldering it. This is the most common thing in the world. It's called a helping hands. This is about the cheapest one you can get. You get one of these off of AliExpress for like $5. Yeah, they're completely bottom of the elevator shaft quality, but it doesn't matter because all it has to do is hold something in place for you. Yeah, there are more complicated ones. Like once you start getting into doing a lot of circuit boards and things, you might want a different one like this that is more adjustable and spring-loaded, but you're getting started. Something like that is fine. And if you can't get your hands on it, don't worry. I'll show you, you can always just turn the thing over and hold it down on the table. You can use Scotch tape. You can use blue tack. There are many ways. All right, so now let's move on to the kit. Something simple. Look, this thing's going to have what? Looks like 1, 2, 3, 4, 5, 6, 7, 8, 9 components. Nothing, what's known as SMD, a surface mount device. Let me show you why. Here are some through-hole resistors. You know, they're not tiny. Pardon me. If we look here, these are a little over 2 inches long. The resistors themselves are a good 1/8 of an inch wide. They're easy to hold, easy to manipulate, okay? Here are SMD resistors. One second. I'm about to have an avalanche over here at the messy part where you don't generally get to see. Okay, here are SMD resistors. Look at and these are large SMD resistors, but just look at the difference in size. You don't want to start out with these. You may never want to go to those, but you definitely don't want to start out with those. It'll ruin everything, just because they are difficult to solder. So here is a Learn to Solder kit called Hue. I've made one of these before. The company is learnetosolderkits.com. These are great. Because the other thing that you're going to want to make sure you get are the instructions. If you're just starting out, you're not going to know what goes where. Does it have to face a certain way? Or even what a good solder joint looks like. So for your first couple kits, I would avoid the super cheap Chinese kits because they're not going to come with any instructions. Hue, on the other hand, does. The instructions can be found there at learnetosolderkits.com. You have a parts list, PCB, battery, RGB LED. See, you're just starting out, you don't know what that means. Resistor, potentiometer, switch, battery holder. So here's our PCB, the printed circuit board. They're made of fiberglass. They're coated in copper, and then the copper areas that aren't used are washed over, and then they're coated with a chemical that other solder won't stick to. This one is actually coated in gold. It's called an Enoch finish, and that's really nice. The reason we use gold for electronic contacts is gold doesn't corrode. It is not the best conductor. If you've heard that, that's a lie. Silver is probably the best conductor in the precious metal group, but gold doesn't oxidize. So it's always nice. And that's important when you're soldering because you need to have a clean surface. Here is a CR2032, just your standard button cell battery. And here are our components. Oh, pardon my wheezing. So we have 3 resistors. This is a 10 millimeter, ow, RGB LED that I just stuck myself in the finger with. So what you're going to notice is it has 4 pins there. This one longer pin is generally the off pin, and you'll see what I mean later. But you have 1 pin for each color, red, green, and blue, R, G, and B. So you have actually 3 LEDs in one package there. These are the potentiometers. They're also known as trimmers, or I think in Europe you might call them presets. Basically, it is, just think of it as a resistor where you can change its value. Here we have a switch, like a little single pole, single throw switch. And this is a battery holder. So those are all our parts. So before you start building, what you want to do is called knolling, and that's spelled K-N-O-L-L-I-N-G. You want to set all your parts out in some logical way that makes sense to you. So there you see we have the battery holder. Variable resistors. Then we just have our LED, our PCB, and our switch. All right, let's get ready to start soldering this up. All right, before we actually get into start soldering it, we're going to talk about a couple of other tools that you don't necessarily need. but are going to make things easier for you. And the first one is one of these solder suckers. Basically, it's just a spring-loaded suction pump. So if you have a bad solder joint or you make a mistake, you can just sit this on it, heat it up with the solder, boom, suck the solder off, and you're good to go. Next is a multimeter. And you should always check the value of your resistors to make sure that they are close to the specified value. Like, let's say you have a resistor that says 330K, and you test it and it reads 340K. Well, that's a change of 10K. That's probably not going to be great for your circuit. But let's say you have a resistor that says it should be 1K, but it reads 920 ohms, or it might say 0.92. Well, that's okay. You're only losing, you know, what I say, 80 ohms there as opposed to 10,000 ohms. What I'm trying to say, I guess, is resistors, any component is never going to read an exact value. That's called an ideal component. They are theoretical. Everything has what are known as manufacturing tolerances. And there are some circuits that only work with manufacturing tolerances. If everything was ideal, they wouldn't work. And I have a video of that on the channel if you can find it there. So anyway, check your resistor values to make sure they're close to what they're supposed to be. All right, so the first thing that we're going to do is start with the lowest component, the shortest components. And in that case, you know, we're looking at the components as they're going to lay on the board, and the resistors are going to be the shortest, whereas the RGB LED is going to be the tallest and will probably be the last thing we put in. So the resistors come in what we call bandolier or tape. Now, because we're going to cut off the ends, you can just pull the tape off. But you see how it's going to leave a little debris there? Solder's not going to want to stick to that. Solder wants to stick to clean metal. But it'll be okay in this case because we're going to cut them off. But generally, what you want to do is just kind of cut them off like this. Just consider the part that are in the tape ruined. So resistors are not polarized. That means it doesn't matter which way you place them in the circuit. They work the same in one direction as they do in another. So I'm just going to bend the resistor legs 90 degrees to the body, put it through the hole, hold it with my thumb, and then just kind of splay the legs out a little bit. And you see that'll keep it in there so you can solder it. Now you could solder one at a time, and we're going to do that in this case just so you can get an idea of what a nice solder joint should look like. But when we do these other ones, we're going to do them together, and that's the way you generally do things. So I'm going to take this and put it face down, just like that. Move the camera here a little bit to give you a better view. I'm going to get my solder ready. And I'm going to get my soldering iron ready by cleaning it to make sure that we always start with a shiny tip. So now I'm going to zoom in here so you get a better view of the actual soldering. So we cleaned. Our tip is nice and shiny now. So what we want to do is just give it a little touch of solder. That's called tinning the iron. And that helps take the heat over. What you do not want to do is load up your iron like this. And then try and bring that solder booger over there and get it to stick. That doesn't work. That makes for a poor joint. What you want to do is like this. Tin the iron. All you have to do is touch it. So like that. Boom. And the solder should flow onto the tip. If it doesn't, your tip isn't clean enough and you need to go back and clean it some more. So now what we're going to do is we're going to take the iron, our hot tip, and we're going to press it down on the pad and up against the leg of the component. So we're touching both things at one time. Hold it there for a second to heat them both up. Bring in the solder. Feed it in, remove the solder, leave the iron on for a second. Take the iron off. Count to, I don't know, 5. 1, 2, 3, 4, 5. And now when you take a look at that, you see we have a nice, shiny, little kind of mountain-shaped joint. Now it's off to the side because we bent those legs. But if it was straight up and down, it would look like a Hershey's Kiss. All right, let's do the other one. Same thing. Bring in the iron, touch the pad, touch the leg at the same time, apply a little force. I'm holding it down. And then we're going to bring in the solder till you see it fill up the pad, remove the solder, then remove the iron. Now you can get your snippers, flush cutters, flat bottom cutters, whatever you want to call it, ready. Inspect your solder joints, make sure they're good. Inspect a component, make sure it's sitting how you want, and then trim off the legs. So try not to cut into the solder blob itself, but instead right above it, just like that. And there's our joint. So I can get it to focus. There you go. There's our joint. There's our components. So I'm going to do the other ones together. But before we do that, I'm going to show you another useful component, and that is flux. This flux I'm using is Uncle Rob's Magic Flux, but any old flux will do. It's made mostly of pine tar with an alcohol thinner type base, and it cleans the metal and it helps the solder flow better. So we're going to do these other 2 resistors there. So that would be these pads here. And all you need to do is just wipe a tiny bit of the flux on, and you're ready to roll. If you don't have flux, don't worry. There is flux in the inside of your solder wire. It's called flux core. You can also find acid core. There are many different types of solder. Just stick with the MG 6040 tin solder and you'll be fine. So you'll notice that this resistor has this one severely different colored band on the end. That's a tolerance band. And just to keep things neat, I'm going to have all of our tolerance bands pointing towards the outside of the board. Electrically, it makes absolutely no difference in the circuit. As I said, these are non-polarized, so you can put them in any direction. Well, you have 2 choices, but you can put them in either direction, and they'll work just fine. It's the same with our last one. And then we'll splay those legs. And this time we're going to do it just a little bit differently. What I'm going to do this time is I'm going to solder one pad, in this case it's going to be the outside pad, of each resistor. So there's one. This is why those holders make it so nice, but they're not absolutely necessary. Okay, so I did one leg of each, and the reason we do that is so you can flip this over, and if the component is sticking out, you see, you can still have a little bit of adjustment there. Whereas if you soldered them both in, yeah, it's a little bit tougher to do that. So let's solder the other pads. Then we inspect. And we snip. So what am I looking for when I inspect? I am looking to make sure that the entire pad is covered in solder. So where we've soldered here, you should not see any gold visible at all. All you should see is the silver solder. Then I'm looking for the shape. It should look something like a Hershey's Kiss. And then I'm looking to make sure that there are no gaps between the solder and the component. Good. So next, we're going to put in these variable resistors. They're not really variable resistors, they're potentiometers, but we use them as that purpose. They have a triangular pattern, which will only fit one way. So that's the way we're going to stick them in. And we're going to find out whether or not trying to do these all at once is actually a good idea. Come on. There we go. So let's see if I can flip this over. Kind of works. All right, so you can hear that scratching. That's just me cleaning the soldering iron. We're going to do these like we did the others. We're going to solder one pin. I didn't even take the solder. There we go. Yeah, we're going to solder one pin of each resistor. It doesn't matter which pin. Just do one of them. Once we do that, we'll make sure that they're laying how we want them to. Now you see me poking around here. That's because I'm soldering through the camera. So I have like no depth perception. It's much easier to do it without a camera in front of you. All right, so we're looking to make sure that they are all flat up against the board as we want them. I got a bent leg here, so I'm just straightening it out a little bit. Good. Now, I'm going to go through and do another leg of each one instead of doing both of them at the same time. And the reason I'm doing it like this is we are reducing our dwell time, the amount of time that we have high heat on the component. The shorter that time is, the less distance the heat can travel into the component. So it's better sometimes to have your iron hotter and be quicker than it is to have a lower temperature. A lower temperature is going to take longer, and it's going to give more time for the heat to soak into the part. And we don't want that. We want as little heat on a part as possible. Now for passive components, and passive, you hear passive components, active components. Passive components cannot change the current flow in a circuit. Active components can. That's a simplified answer, but it's a good one. So like resistors, capacitors, potentiometers, LEDs, these are all passive components. Transistors, MOSFETs, which are just another type of transistor, these are active components. They can actually change the current flow. Yeah, anyway, what I was getting with is you really can't damage resistors and stuff with, staying on there with a little too much heat. I mean, you could if you did it for like an hour, but a few extra seconds is not going to make any difference. Whereas a component like, say, a transistor that has 2 silicon junctions in it, well, that is not going to like all that heat. So you want to be in and out of there as quickly as you possibly can. And you hear I'm cleaning the soldering iron every couple of joints. Now we're going to go back over here, do this one, and this will be the last of these. So one of the questions I get asked a lot is, how long do you have to keep the heat in the soldering iron on the part you're soldering? Well, until you see the solder flow. All right, so let's do this one right here. And I'm going to see if I can't get you a better view. All right, let's try this. This is going to be interesting. Pardon me while I manipulate the soldering iron and everything around. Okay, so here we go. Iron is on the pad and the leg. Now you can still see that little bit of gold right there, right? Now can you see it? No, because the joint is done. Here, I'll do one more, the last one of these. We're heating up the joint. You can still see the gold under there. Now the gold is gone. The solder has covered the entire joint. So now we just need to trim off the excess from those little legs there. Remember, just above the joint. Leave the Hershey kiss, take the streamer. That is what the gentleman, I shouldn't call him a gentleman, he'd be very offended if I called him a gentleman. That is what the chief who taught me to solder would say. Hope you're still out there, hope you're still alive, Chief Lopez. All right. So next up, we probably should have put this one in before. We're just going to put in this battery holder. And I'm going to put it so we slide the battery in from the outside of the board. Now, if I turn this upside down and try and stick it on there, it's not going to work. It's going to fall out. So a little piece of tape will do. In this case, I am going to use blue tack. This is blue tack. It's just like a sticky putty that doesn't dry out. So what I'm going to do is I'm going to hold this down with my finger and then just kind of wedge the blue tack. And now you see that is in there. And I'm once again going to do one leg. One leg, and then we're going to check it. We can take the blue tack out now because it is on the board now. Well, I made it do that when I pulled the blue tack off there. So is it sitting how I want it to sit? Well, it's a little bit angled there. So what we can do is we can take our soldering iron, heat that joint up, and then click it back down in place. Now we're flat. That's why we do one at a time. It allows you to adjust. So now I'm going to do the opposite corner here. Grab this one. Now that I've done two opposite corners, this thing's locked in place. And we can do the last couple joints. Real easy. Because we don't have to worry about the part falling off the board. Now, the excess on these barely stick up, but I'm going to cut them anyway just to be consistent. You don't really have to. All All right, look at that. That is an incomplete joint. See that? See, that's a bad one. That is why we inspect. So we're going to come back with our nice clean soldering iron. Tin her up. The problem was I didn't give it enough time or enough solder. There we go. Now, everything is copacetic. Okay, next is going to be our switch. Three-way, single throw, single pole switch like this. Doesn't matter what direction you put it in. So I'll just stick it in like that. And again, I'm going to use the blue tack to hold it in place. Now, it's just me, but when I line up vertically as opposed to horizontally with components, it's just easier for me to go down the line like this. Might be easier for you to go the other way. That's just preference. See, that joint is not... Now, that one took a little bit of manipulation to get the solder around there. By manipulation, what I mean is I just kind of took the soldering iron and I was just kind of pushing it back and forth like that a little bit, just until I saw that the entire pad was covered in solder. And once I saw that, I knew it's good. So take our blue tack off. Trim our legs. And we got one component left. And that component is our RGB LED. So you see how we have the square and all the others are circle? We'll notice anything different. We have one long leg that goes in the square. And the others go in the circle. This can be a little bit touchy, so I'm going to spread these out a little bit. If you can get the legs of your components to match the holes, makes your life a whole lot easier. And you notice I said if, because it doesn't mean it always happens. So now we're going to decide how high up off the board we want this. We don't want to pull it too tight down there, but I think right about there. So for this time, because I don't want to knock this off kilter, I am going to use the helping hands and just clip in here like so. Good. Now I can see our soldering area. Let's zoom you in a little bit. Clean the soldering iron. Tin it. And here's, let me zoom out. Here's another trick. I am resting my soldering hand on the table. Now my solder hand, I'm going to put up here like this. So I'm solid, and all I'm moving are my thumb and finger here. So I check that is still in the position I want, and it is. And we'll do the next one. Clean tin and we solder. All right, now, when we do our inspection, we're going to look for something else as well called a solder bridge, where two or more of those solder pads could possibly be touching each other. And that will create a short circuit. But as you can see, we do not have that, which is good. We don't want to have that. Trim our legs off. Yeah, you hear them pinging all over the place. That's what happens unless you hold them. I have found a trick to deal with it. I just use a magnet over the tabletop and the carpet picks everything up. So now I'm doing a final inspection, looking at all of my joints to make sure that I don't see any of the pad. All of my joints are not, or none of my joints are misshapen. Okay, so off, on. Let's get the battery. So this is an RGB LED. Like I said, it's actually 3 different LEDs, red, a green, and a blue, all in one package. And we can control and manipulate them together. So we can change, by changing these potentiometers, we can change the color of these bulbs. Here's what I'm going to do. I'm going to set all of them all the way left. And then we'll put the battery in. All right, I don't know how well you can see this, but right there on that little tang is a plus sign. So I assume that's the way the battery goes in. Oh yeah, it's on. Let me kill some of these lights here. So here we have a nice blue. And of course there's the switch. Shut it off, turn it on. We will adjust the red. So by adding in red, we should get more of a purpley color, which we kind of do. Now we'll add in some blue. Oh yeah, there's nice and purpley. Finally some green, and we should go just about white. It's a little green tinged white. So let's turn the blue down and the red down. So all we have up now is green. So there's our green. Turn it down. There's our blue. And there's our red. Cool. That's a very pretty sunset-like color. So friends, that is how you put together a simple DIY electronic kit. I'll put a link to this kit down below if you're interested, but any simple kit will do. And now you have the skills you need to have some fun and build some of these kits, which you can give away. People love stuff like this. It's like a fidget spinner. All right, I hope you enjoyed this. If you did, give me a thumbs up. Feel free to comment and share, and don't forget to subscribe. Big thanks to all the patrons. Big thanks to you for watching. That's it. I'm out. Peace.